Alright, so question 3, we are given this C1. So C1 we are given the standard equation, then the C2 is the general equation, right? So they want us to find the coordinate and the center of the circle C2 and its radius. Or same thing, it's just completing the square. If you complete the square correctly, right, you should be able to get the center of circle to be -1, 8, right? And of course the radius of circle to be 4. So for this part, I'll leave it to you. Okay, what about for part 2? Part 2 is a difficult one. So they want us to show that C2 lies completely inside of C1. Okay, so for C1 wise, you will see that my center of circle is 4, 6, right? So 4, 6 is roughly right here. Then the C2, the center of circle is -1, 8 and radius 4. So first thing, how do I show that C2 lies completely inside? Very simple. First, you find what is the distance between C1 and C2. So you use the length formula, right? So x1 minus x2, so -1 minus 4 bracket square plus 8 minus 6 bracket square. So this will give you 25 plus 4, which is equal to square root 29. Okay, after that, we know that the radius of C1 is roughly 10, right? So, okay, let's just say I draw. So this is 10. Okay, so this whole thing is 10. Then, I draw this first. Okay, so this is radius 10. Then for the C2, the radius is 4, right? Okay, so this is, okay, for example, I right here 4. So this will be 4. Okay, of course, you can see, right, if you use the distance between C1 and C2 plus 4, it's still lesser than the radius of C1. So that's how you prove. So you just need to write down, since distance of C1, C2, right, is equal to square root 29. Then you add on plus 4. So from C1 to the circumference of C2 is actually equal to square root 29 plus 4. So this will give you roughly 9.39 units. So this 9.39 units is lesser than 10. So this one is lesser than 10. Hence, C2 lie completely inside C1. Yep. Okay, so if I draw the circle, which is not very nice, so this will be C1. Okay, for example, I just draw a big one. So this will be C1, right? Then for C2 will be like this. Something like that. Yeah, so this is the picture of C1 and C2, which is not very nice. So you just need to find what is the distance between C1 and C2. So it's square root 29, right? Then you add on 4 units, because the radius of the C2 is 4 units, so it's roughly 9.39. So definitely it's less than the radius of C1. So then after that, just prove already. So that's how you do question 3.